So hello everyone, welcome to session number 3 for the design of 4-bit CLA adder using custom compiler tool in Synopsys. So in session number 1, we build a generate circuit and verified in the test bench its functionality. Session number 2 was about building the propagate circuit, right? And verifying its test bench in custom compiler. So far we have created various cells in the library in custom compiler. So today we are going to focus on energy towards building carry 1, carry 2, carry 3, carry 4 circuits, blocks, and the sum module or the block, right? So let's get started. So first of all, let me show you how the carry circuits are being implemented. So carry circuits are implemented using CMOS mirror logic. So here the expression goes as follows. C of I plus 1 is equal to Gi plus Ci into Pi. So this is how the carry 1 blocks looks like. So if you go by the analogy, we'll have if I is 0, so C1 will be equal to G0 plus C0 P0, right? So this, if you want to implement in your CMOS mirror logic, it will look something like this. This is my pull-up network with the PMOS transistor with the inputs G0, C0, P0, and that's my pull-down network with the NMOS transistors with the input applied to the gate terminal P0, C0, G0, and the output is C1 bar, right? That is also required. So we require C1 bar also for the sum circuit, and we pass it to a CMOS inverter to get C1. So let's start building this circuit first in custom compiler, and then we'll come back to the next modules, right? So the process of creating a schematic is already explained to you all. So first of all, you have to create a new cell, name that cell, and then create a view. Go to view, again create new, and then go to the schematic editor. So we have already, to save time, I've already created this carry 1 block and already created the schematic. Let us check the schematic in detail. Okay, I'll go to view and I'll go to full screen mode over here so that we can have a full view of what we have done so far. Okay, so let me just cross check it whether it's let me adjust the screen so that both the screens are visible simultaneously. Yeah, let me adjust the custom compiler tool also, the window. Yeah, now let us test the circuit out. Here we have applied, let me maximize this part also. Yeah, these are all PMOS transistors whose body terminal is connected to VDD. We have used the labeling technique, and here we have G0, C0, and P0. So the upper section pull up network, it's absolutely behaving fine, and we have applied over here VDD. So this VDD pin G0, C0, and we have P0 which is applied down, I guess. Yeah. So these are the input pins now. And now, and this side we have a CMOS inverter. So this is that CMOS inverter which we were talking about. So before the CMOS inverter, we have C1 bar that is also required. And we also require C1. So these are the pins. Okay. This is a input output pin. So whenever you select a pin, there will be an option whether it should be input output or input output. So since this is an intermediate signal, we are calling it as an input output C1 bar, right? And then in the lower section, we have, let us check it out. We have P0, C0, G0. So since P0, G0 and C0 is already marked by label above, we need not connect the pins again. We will just use the label of the wire, right? And for the NMOS transistors, all the body terminals are connected to VSS, which is normally the ground. Fine. So this is my C1 carry block. Now, after creating the schematic, what you need to do is, let me go back to the window and go out of the full screen. After creating the schematic, you have to create a symbol for that schematic. So you need to go to design, and in design you go to new cell and click on from view cell. So once you click on that, then click on OK, you will get a symbol of it. Uh, we have already created that symbol. So for this carry one block, the inputs are C0, P0, G0. The supply pins are VDD and VSS, and the outputs are C1 bar and C1. Okay. So before the inverter and after the inverter, C1 bar and C1. So this is how the symbol will look like, right? So this we have created the carry one block. Right now, no need to test it out, right? We will add it, the entire circuit will club it together and then we'll create a test bench. So this is how we create the carry one block. Similarly, we'll start with the carry two block also. Let me go to carry two block. So carry two block is C2 is equal to G1, P1, C1. Now we know that C1 is given by G0 plus C0, P0. So we substitute it over here and we create a circuit out of it, right? Using CMOS mirror logic. So this is the circuit which will give you carry two output. Okay, here you get C2 bar. Once you connect a CMOS inverter, we'll get C2, right? So let's build this up. So the pull-up network consists of all PMOS transistors. Pull-down network consists of all NMOS transistors, right? So let us start with the building of the schematic for carry two circuit. So let me just slightly minimize this part. Okay, this is the carry two circuit. So let me close this and open up the carry two circuit. So carry one block is over. Okay, no need to create a test bench for it. For carry and sum, directly you create just the block. So in this session, we will just create blocks for modules for carry one, carry two, carry three, carry four, and the sum block. So next we have to create the carry two block similarly, right? I've already done that process. We have done that process for in the first session, so I'm not repeating it. I've already created a schematic. Let's view it in detail. Let me go to the full screen and explain you that it's exactly in the same fashion mentioned over here. So let me maximize the screen a little bit. Yeah. So this is the upper section. Upper section we have VDD. Then all the PMOS transistors body terminal are connected to VDD. Then we have G1 transistor, G1 applied to the gate of PMOS transistor first. Then G0, C0, right? You have applied the input pins also, G1, G0 and C0. Then we have P0 and P1 connected to the gate terminals of PMOS transistors over here, right? We can check out this connections, it's absolutely fine. Then let's go to the bottom network. In the bottom network, we have VSS. Then here we have P1, P1 applied to the input gate terminal of NMOS transistor. Then P0 and C0. Remember they are labeled. So C0 is already labeled above. No need to apply a pin again, right? Only P0 and P1 is left. So we have applied the pins to P0 and P1 input pins, right? Then we have yeah. So over here we have G0 and G1. Okay, we have G0 and G1 block. Actually, this G1, G0 block should be connected over here. We'll connect it. We'll do the corrections now. Right now, let me start. Yeah. So now this G1, G0 block connection is made properly. The source terminal is going over here correctly, and this G1 source terminal is going to the ground. Remember, all the body terminals of our entire, all the NMOS transistors are connected to the VSS, which is ground. And then we connect over here at the output side. Let me select a hand tool so that I can move easily onto the screen. Yeah, I've selected the hand tool. Now I can move the schematic here and there. Now we'll connect the CMOS inverter. So here output is C2 bars, right? And over here we get a CMOS inverter and we'll get C2 at the output, right? Any problem in understanding this? This is my PMOS and this is my NMOS transistor. So this is my schematic for, C2 block. Okay, C2 carry block. Now I have to save it and check and save. There are no violations. Let me check the console terminal. Yeah, there are no violations now. Now we have to update it in the, let me go out of the screen. You have to go to design and then create a new cell view and click on from cell view. It will create a new symbol. So we have already created a symbol over here. This is the symbol. Okay, this is the symbol for carry 2 block. Here it is C0, G0, G1, P0, P1, C2, C2 bar, VDD, and VSS. Right now, since we have done some updation in the circuit, what we will do is we'll go to design and update cell view. That updated cell view will be transmitted to the symbol. So yeah, so that whatever corrections we have made, that is updated in the cell, updated in this symbol, right? So let's say one connection was wrong. That is what we have done the mistake over here of connecting the source terminal of this transistor to the ground. So we have corrected it right now, right? So this will give you perfectly, perfect output now, right? For C2 carry block. So in this way, we have completed the C2 carry block. So C2 carry block will have the inputs C0, G0, G1, P0, P1, right? And the output is C2 and C2 bar with the supply pins VDD and VSS, right? And now we can close this schematic. Now we'll go to C3, C2, C3 carry block. So C3 carry block contains C3 is equal to G2 plus P2 C3 plus P2 C2, right? So it contains this additional term of C2. So over here, we can implement using this logic now. CMOS current mirror logic. CMOS mirror logic, not current mirror, mirror logic. So this is the schematic for it, right? So let's check it out, whether this works. Yeah, here it is. C3 is G2 plus P2 into G1 plus P1 into G0 plus P0 C0, right? So that is how this is implemented using CMOS mirror logic, right? So let us test it out. I have already have a carry block, carry 3 block. Let me go to the schematic and let us test it out whether the schematic is properly, made or not. Like last time we have identified a mistake. So let me click on this button and let us check it one by one if everything is correct. So here we have VDD supply, right? We have G2, G1, G0, C0. So far so good. All the PMOS transistor body terminal is connected to VDD. Then we have P0, then we have P1 and P2. Yeah, up till here it's correct. Now let's check the network below. Below network consists of all NMOS transistors. So we have P2, P1, P0, C0 along with the pins, input pins. All the body terminals of NMOS transistor are connected to the VSS, which is ground. Then we have G0, G1 and G2. So everything so far is correct now. And then finally we connect a CMOS inverter at the output to get C3, because the output of this block is C3 bar and we'll get C3 from here. So this is absolutely correct. No problem with the design. Let me zoom out and let me go to window, full screen, out. We have to create a symbol. I've already created one. How to create a symbol? Go to design, go to new cell view and click on from cell view and click on OK. So I've already done that. Let me go to the library manager and show you the symbol. So this is the symbol. Here we have inputs for carry 3 block as C0, G0, G1, G2, P0, P1, P2. And supply voltage is VDD and VSS. And here the outputs are C3 and C3 bar, right? So this is how you create your carry 3 block. So this will be your symbol for your carry 3 block. Now let's make the carry 4 block. So carry 4 block will be a little bit huge again. So your C3 from earlier expressions we have got, we'll use as it is. So C4 is G3 plus P3 C3, whereas C3 is this huge expression, and we implement this using the CMOS mirror logic, right? So this is the circuit, this is the pull-up network, right? And that is the pull-down network along with the CMOS inverter at the output. So here we have C4 bar and C4, right? So now let us test it out. We'll already created a cell for the C4 block. Let's go to the schematic. So you have to create the schematic. Right now I'm showing you all whether the schematic is proper. So you have to, I've already shown in the session number 1 how to do that. So you have to take that initiative and complete that design. Now let me start with the pull-up network. So here we have, okay, here we have G3, then we have G2, G1, G0, C0, right? Internally we have P0, P1, P2, P3. So it's correct. All the PMOS transistors, VDD, I mean body terminal is connected to VDD. And then let's check the pull down network. So pull down network consists of all NMOS transistors. So here we have C0, P0, P1, P2, P3. Here we have G0, G1, G2, G3. So yeah, all the connections are proper. And the output is C4 bar. And once you connect a CMOS inverter over here, we'll get C4 at the output. So yeah, this circuit is also exactly, proper, no problems with it. Now, only thing is you have to create a symbol. So for that, you go out of the full screen view, then go to design, go to the new cell view, and then click on from cell view. I've already created a symbol for it. I'll show it to you all. So this is the symbol created for the carry 4 block. Here we have C0, G0, G1, G2, G3, P0, P1, P2, P3, C4 and C4 bar. We have VDD and VSS. So yeah, so that is what we get over here, the carry 4 block symbol. That is what you have to create so far. We'll interconnect them all together very patiently, right? So don't worry about that. Now we'll close this and we'll close this. Now we'll go to the sum block. We have created the carry 1, carry 2, carry 3 and carry 4 block. Now we'll go to the sum block. So sum is implemented using CMOS mirror logic again. So SI is equal to GI CI plus CI plus 1 bar into PI plus CI. So if you want to implement S0, it will be S0 is equal to G0 C0 plus C1 bar into P0 plus C0. So that is what we will have implemented over here using CMOS mirror logic, right? So let's build a circuit in custom compiler and see whether we can build this perfectly well. So I've already done that. Sum block I've created. Let's check the schematic. Again, let me go to the window, click on the full screen, right? And then let me go to the magnified mode and check out the schematic, right? Now let's check it out. Here I've called it as PI GI because we will be using a generalized sum block. So here we have CI GI. Okay, CI bar. Here we have written okay, I guess we have interchanged that. Here it is GI, here it is G0. Okay, I guess there is some mistake over here. No, it's absolutely fine. Let me check. Yeah, this is P0. Okay, this is P0, not Let me check it out. What was the problem? Yeah. So this is correct. This block is correct. G0, C0. Yeah. C1 bar plus P0 plus C0. So here it is correct. And here this should be P0 instead of this. This should be P0. So we need to correct that. Yeah. So similarly, we have to correct here also. We'll check it out in the carry in the sum block. So here let's check the below one. So here we have, okay, I am checking the wrong circuit. This is the sum block. Yeah, this is the sum block. So here we have GI, CI, that is correct. Here we have CI, C1 bar, that is C1 bar only. This is P0, C0. So that is perfectly fine. And in the above network, we might have to do some corrections. So over here we have G0. Yeah, this should be G0 and this should be PI, right? So that we have to interchange. So this should be, let me double click it. This should be PI. Okay. Okay, P double I it has become. So this should be PI. Because this is wrong over here. This should be P0. And this should be G0, G0, C0. Okay. So this symbol over here, this should be, label should be DI. And this name which we have given should be DI. Okay, fine. And if you go below, we have already given GI over here. We have to give it to PI also. Let me check it out once. Yeah, the design is correct. Absolutely fine. No problem with it. P0, C0. Yeah, let me check it out once. Yeah, no, actually what we have done over here is in the sum block, the one outside, this should be P0 only. So it was correct only. So we'll go back. Yeah, no problem. It was correct. It was GI and this will be P0 only. This should be P0, C0. Okay. So we have corrected that. Good. We have identified that there was no mistake. And this is C0. So this entire sum block is correct now. And at the output, we have SI. That means in general, we are adding SI, but this should be S0. Fine. So the sum block is proper now. No problem with it. Nothing has been updated. We check it. There are no design rule violations over here. Always important to check and save your design. There is no design rule violation. Okay, and nothing we have to update. It's absolutely fine. Sum block is absolutely fine. Now we have to create the full, go out of the full screen. Let me click on OK on the console. Now we have to create a symbol for this sum block. I've already done that. So they'll just double click on the, we have just double click on the symbol. So here we have, for sum we have CI bar, yeah. So here we have CI bar, GI and PI as the inputs and SI will be the output. Yes. And VDD and VSS will be the, supply pins. Okay. So this is how you create the sum block. So far, we have not created any test bench. We have just created the modules. Let me show it to you. We have created the modules for a carry 4 circuit, carry 1, carry 2, carry 3, and some block. In the next session, we will integrate them together to make it as a 4-bit CLA adder. Okay. So next time we will do that. Fine. So I think that's all for this session. So in today's session, we have built up the, let me show you the cells now. Okay. Let me close this. So far we have created so many cells. We have created today carry 1 block, carry 2 block, carry 3, carry 4, and we have also created some block. So total blocks we have implemented are propagate, generate, carry, and sum. So that means in this modular design, all these sub blocks or the sub modules are ready now to integrate them together. So in session number 4, we'll integrate them together and we'll check the functionality of this 4-bit CLA adder, right? So yeah, that's all for this session. Next time we'll directly, build up your 4-bit CLA adder by integrating all these cells together. Oh, right? So that's all for today. Thank you, everyone.